Hi everybody, this video is going to be about tangent planes and normal lines. So tangent plane, if we've got some surface, tangent plane at some point is going to be a plane that is tangent to the surface at that point, in the same way that tangent line is tangent to a curve at a point, sort of touches it just at that point and is parallel right around that point, sort of going in the same direction. Tangent plane is going to do the same thing for a surface. So if I've got some point, there's, say, the tangent plane at that point. Of course, it would extend in all directions off forever, but we show this sort of truncated version so it doesn't mess up the picture too much. So how are we going to find this thing? Well, if we remember, we introduced the gradient, and we've talked in class about how the gradient is orthogonal to level curves on a surface at any given point. That is, if you, at any point, there is some level curve, and if we look at the gradient, which we know points in the direction of greatest increase, at that point we know that's always going to be orthogonal to the level curve there. Well, one dimension higher, if we're thinking about a function of three independent variables, so we don't have level curves, we have level surfaces, and since the gradient excuse me, is pointing in the direction of greatest increase of the value of our function, that's going to be in the same way orthogonal to our level surfaces, and we can take advantage of this to help us figure out equations for tangent planes. And the trick is this, really. So if we've got some surface where z is some function of x and y, we can express a related function, I'll call it capital F, of x, y, and z that's equal to 0. For instance, what we're doing here is, so z is this function of x and y. If I just move everything over to one side, I get some function of x, y, and z that's equal to 0. And if I do that, if I've got this function of three independent variables, then in this case what it has are level surfaces. Specifically, our surface is one of those, and the gradient then is going to be orthogonal to that. Because what do we need to come up with the equation of a plane? Well, if you remember from back at the beginning of the course, what we needed was the coordinates of the point that we want the plane to go through, and a normal vector, a vector that's normal to that plane. And if I've got a normal vector and a point, we could write down the equation of the plane. And really, what that is just the normal vector dotted with a vector that's in that plane. So if the point x, y, z is in the plane, then for some, or x naught, y naught, z naught is in the plane, then some arbitrary point x, y, z, the difference of each of those coordinates, that's going to be the coordinates of some vector in the plane. And so the plane is described by the fact that the normal vector dotted with the vector in the plane will be 0. So that's where that equation comes from. And that's that piece there, that's that vector in the plane. Okay, well, so if I've got a point on some surface, then the gradient of that capital F function is going to be orthogonal to that surface, so that's my normal vector. And I could just write down the equation of the tangent plane. I dot the gradient with a vector in the plane, or written out, I get it this way in terms of the partial derivatives, because that's what makes up that gradient for my rectangular coordinates. So here's the equation for a tangent plane at some point. So let's practice. Take a moment and make sure you can find the equation of the plane that's tangent to the surface described by this function at the given point 1, 1, negative 4. If I didn't mess anything up, we should find that the gradient at that point is given by the vector 6, 4, 1. And so that means then we could write down the equation of the tangent plane with this equation. And so the picture, that surface, looks looks like this. And there's the point that we're curious about. And here's the tangent vector, or sorry, tangent plane at that point. Okay, and then just one more concept to cover quickly is a normal line is sometimes useful to be able to find an equation for. And so a normal line is one that passes through some point which is on a surface, and the line is orthogonal to the surface at that point. Well, if you remember how we came up with the equations of lines with the vector valued functions, if we've got the point and then we just added a scalar multiple of our parameter t times the vector in which we want the line to go, the vector whose direction goes in the direction we want the line to go in. And so if we want something that's orthogonal to the surface, then that gradient is exactly the perfect vector for us there. And so we can just write down the equation of the normal line this way. So take a moment and see if you can come up with the equation of the normal line for the surface we just discussed at that point, and I'll see you in class.